we're now going to get into the different properties of logarithms. Because logarithms and exponentials are inverses of each other, then the properties of logs are going to look extremely similar to those properties of exponents. Okay, so the first rule we're going to look at is the multiplication rules. So if you notice inside the parentheses here, we have multiplication going on between x, y. So what this is going to become is log base A of x plus log base A of y. Okay. So we're going to add what's being multiplied. I think I spelled multiplied wrong. And separate it. So for example, log base 3 of 6x is log base 3 of 6 plus log base 3 of x. Now, we can also, go backwards. So we can go from expanded to condensed. But we will go over this tomorrow. The next rule, the opposite of multiplication, is going to be the division and or quotient rule. And it's just simply going to be the same thing that the multiplication rule was. However, because division is opposite of multiplication, and when we have multiplication we added, we're just going to take the opposite of addition, which is subtraction. Okay? So, same deal. We're going to subtract what's being divided and separate it. So, here I have log base 2 of 1. I have the division, which means subtraction. Log base 2 of 3. And then again, tomorrow's video, we will go over going backwards. The next one is I have a power rule, just as I had in exponentials. What this is going to become is x log base A of B. Okay, so we're going to move exponents in front of the log. So again, I have my exponent here, which is 2. It's just going to go in front of the log. So 2 log base 5 of W. And again, we'll go backwards tomorrow. The next one is the same base rule. Okay, so if log base A is of x is equal to log base A of y, then you can simply say x is equal to y. So if logs have the same base, then the again, I call them operators. It's probably not the correct word. Here it would be our variables. So here I have log base 9 of p, log base 9 of k. So I will just say p is equal to k. Do a handful of examples here. Number 17, I have multiplication, which really means add. So log base 4 of 6 plus log base 4 of x. Now again, because we're changing, right? We're changing the way something looks. I can go y equals log, so functions, miscellaneous. I have a log with the base of 4, log base 4 of 6x. I get a graph. Then I say, well, the answer log y equals log base 4 of 6 plus log base 4 of x. Right, this will be my answer choice. I know that I've done it correctly because the graphs overlap for all of the positive x values. All right. So because I'm changing the way it looks, right, I'm changing the form, going from expanding to condensing, condensing to expanding, I can verify, I can know that my answer is correct by graphs overlap again. Okay, so take what they give you, Desmos and y equals, take your answer choice. Y equals, if your graphs overlap for the positive x values, then that's your answer. If not, cross that particular answer off, move on to the next one, so on and so forth. What I want to do one more. I can't even call it a really tough one, right? It's extremely procedural. You just look and, right, you work your from the outside in. So I have an exponent. After I take care of that exponent, I'm going to have division. After I get rid of division, I'm going to have multiplication. So exponent means I bring that 2 out front. So 2 log base 3 of 6x over y. After I did this, I said I need to take care of division. So 2 log base 3 of 6x minus, right, because division becomes subtraction, log base 3 of y. After I do that, I have multiplication, which is really addition. So 2 log base 3 of 6 plus 2 log base 3 of x minus 2 log base 3 of y. And I think that's my answer. Again, I worked through it pretty fast. I could have messed up. I'm going to know that I messed up if my graphs don't overlap. Now, in this one, again, I have 2 variables. Remember, we have to use all the rules we've learned in Math 3. So because I have 2 variables, I'm going to let x be equal to a. I'm going to let y be equal to b. I'm going to choose 3 values for each a and b. So 1, 2, 3, 5, 6, 7 for b. So y equals log base 3 of 6. Now, because I have an x, I'm really going to put an a divided by y, so I'm really going to put a b. And that is raised to the 2nd power. I'm going to add a slider for both a and b. And then my answer choice was a long one. It's 2 log base 3 of 6 plus 2 log base 3 of x. X is really a now. Minus 2 log base 3 of y, which is really b. So if I look at these values, I can see that log base 3 of 6x divided by y raised to the power of 2 is not what I have as my answer choice. So 2 log base 3 of 6 plus 2 log base 3 of a minus 2 log base 3 of b. The reason I know this is not right is because when I evaluate it, I have different answers. So I'd have to zoom extremely far in. Don't forget to put y equals like your teacher. But if I zoom in, I can see that my red and purple graph aren't overlapping. Now, again, because I can tell you that my answer is not right, because graphs don't overlap. Okay. Now, if you wanted to go back and find where the mistake was made, you could, and that's where taking your time and doing this for each of these, right, step by step by step by step is nice, because as soon as my graphs don't overlap, I know I've messed up somewhere. For the sake of time, I'm not going to go back and find it. But again, graphs overlap is how I want you to go through and do these, right? That's how I want you to go through and test your answers.